Alright, good evening, class or kids. Tonight we're just going to fill out part of our foldable. It's just going to be very basic and simple. We can thank Mr. Johnny for making it all neat and pretty. We're going to kind of just recap what we did in class today with independent, dependent. Independent, remember, your independent determines, so your independent determines your dependent. So whatever occurs, the cause, remember we talked about kind of being like cause and effect, the cause leads to your outcome, your aftermath. So your independent determines what happens with your dependent. So on the flip side of that, your dependent depends on your independent. Okay, depends on are very important words because you will see this one a lot in the word problems on the test. A lot of times on the test, they will give you the answers in the word problem if you just read your sentences. Okay, so anytime you see that something depends on something, understand that it's your dependent that depends on your independent. So think of it like you with your guardians or your parents. You depend on your parents. For, a house, for food, you depend. You are the dependent variable. The other common way it is written in the test is it will say is a function of. This one is also dependent is a function of independent. So is a function of is another way they will put it in the word problem. They will say, something is a function of something else. And then they'll continue on with their story, and then they'll ask you for the independent or dependent variable. And you have to know that it's the dependent is a function of your independent. Now, independent comes first. Now, when we say independent comes first, do not think that we mean it comes first written. Does not mean it's the first thing in the word problem. When we say it comes first, we mean it occurs first. Not that it is written first. So understand that. Your independent is what occurs first. Okay? Your dependent changes because of the independent. So your independent has to occur first, but your dependent changes because of it. And then these two are very common. Understand that X is your independent and Y is your dependent. Now, it was not written down there. We thought about this after we created these notes. But over here to the side in the corner, I want you to put a little asterisk. And I want you to write a variable is not a number. Okay? So please remember, on problems, when we ask for the independent and dependent variables, we are not asking for a specific number. Okay, if that becomes an answer choice, if there is a number in your answer choice, you can eliminate that number right off the bat. A variable is not a number. Okay, a variable represents a concept. So moving on down, if we read the first problem, it says a repairman charges $20 to make a house call, plus $55 an hour for labor. What are the independent and dependent variables? Well, what are the two things that are going to happen? Okay, well, we know the $20 doesn't change no matter what. No matter what, he's going to charge that $20. But what does change? Well, what changes is the hours of labor. What changes is your hours of labor. And then the other thing that you need to know is your total cost. So even though it doesn't talk about total cost here, you know that's going to be your outcome. Okay? Your total cost is your outcome. Your total cost changes because of your hours of labor. So think about what has to occur first. Well, what occurs first is your hours of labor. So that would be your independent variable. Your independent variable is your hours of labor. So that occurs first, and then your total charges, what you pay, depends on that hours of labor. No matter what, you're going to have to pay $20 plus the $55 per hour. So if we were to write this as an expression, it would be $20 plus $55 per hour the repairman works is going to equal our total charge. It's going to equal our charges. So in our in what we did today, our notes today, I told you your input is always your independent variable. Your input is your independent variable. Your output, your answer, is always your dependent. Now, over here with your table, mapping, graph, and your relation and equation, we just want you to visually see which is which. So y'all kind of already seen this today. Know that your table, your X, is your independent variable. I'm just going to abbreviate. Your Y is your dependent variable. Mapping, this is called mapping. Remember, mapping is when they have numbers here, and they draw the arrows to connect to numbers and so forth. That's called mapping. Okay, but the numbers on your left side is your independent. The numbers on your right are your dependent. On a graph, this is your x-axis, this is your y-axis. Your x-axis is always your independent. Your y-axis is always your dependent. A relation. Some of y'all don't even know what a relation is. A relation is just an x and y. It's just a relationship between x and y. Your x is your independent. Your y is your dependent. An equation, you should know this. Your x is your independent. That is your input. And remember, n, okay? And your y is your dependent. That is your output. It's your answer. Okay? So that's enough for independent and dependent. Real quick, I also want to cover continuous and discrete. This is new to you, so please pay attention. So you need to go to continuous and discrete. This is very simple. We will talk more about this throughout the week. But the key thing to know about continuous are your connected graphs. So continuous means they are connected. So some examples of connected graphs are like this. Okay? That would be continuous. It has a line that connects. It is connected. Sometimes y'all will see scatter plots like so, but if they are connected, then that means they are continuous. Okay, so anytime a graph has lines that are connected, that is a continuous graph. It's very simple. A discrete graph is the opposite. It means they are disconnected. And the most common discrete graph is a scatter plot. Okay, that is the example. If you want to write the word example above here, you can. Okay, that is the most common example of a discrete graph. So you just make sure you know a scatter plot is something like this. If there are dots everywhere and they are not connected, that is discrete. Okay, and over here you may just have something like this, and it may be And it may be you marking points. But it's still if it's something like this, if it is not connected, that's still a discrete graph. Another thing about discrete too, if you want to make a note, you cannot take partial amounts. Of the x values. And what I mean by that is if you're talking about, if you have a graph and you're talking about people down here and whatever your dependent variable is over here, can you talk, if we have 50 people, if you have 100 people, 150 people, can you take partial amounts of these people? Can I say I have 48.5 people? Well, no. You cannot have 48.5 people. So this would be a discrete graph. Okay? You cannot take partial amounts of your x values. Alright, that pretty much covers discrete and continuous. Come ready for tomorrow. We are going to continue with independent and dependent, and we have some activities for you tomorrow. Have a good evening.